All right. Thanks for attending our webinar today. I'd like to introduce, my name's Buck Nye, president of HC&I Company. We appreciate that you've taken the time out of your day to join us. Today, we're going to have Bill Gray from GPS talking about using a needlepoint bipolar ionization to reduce particles, odors, pathogens, and energy. And without further ado, Bill, take it away.
Thank you very much, Buck. Glad everybody could join us here this afternoon. What we're going to do is we're going to talk about global plasma solutions technology. It's called needlepoint bipolar ionization. It's very different from bipolar ionization that you may know today that has tubes. Some of it's known as coronavirus or corona discharge, excuse me, and also known as dielectric barrier discharge. So needlepoint bipolar ionization basically is a tubeless technology, no replacement parts, and no ozone production, which we will talk about in detail here moving forward. Global Plasma Solutions has started up back in 2008. A fellow by the name of Charlie Waddell, which some of you may know, started the company up and in Savannah. He now holds 54 patents. I think 27 of them have been granted, and it's all based around needlepoint bipolar ionization. Charlie sold the company a year and a half ago to a company in Charlotte called Falfurious Capital Partners. They've done a great job in getting us everything that we might need. A new marketing team, new websites, adequate warehousing facilities. So we're moving forward in a big way these days. So with that, I'll move forward and we'll talk a little bit about ionization. You're going to have high densities of ionization, which occur naturally. Ionization obviously has been around for years, but at high elevation, you'll have probably 5,000 ions per cubic centimeter. As you come down in elevation, you'll probably come into more areas where you have higher populations, and that ionization is eaten up by the pollution that you're running into. As you come down into an area that you're sitting today, outside you may have less than 200 ions per cubic centimeter, and that's how ionization is measured in ions per cubic centimeter. Inside where you're sitting today, unless you already have our technology producing ionization in your system, you probably have less than 100 ions per cubic centimeter. What we are doing is artificially generating the same ionization that would occur by nature, occur naturally, and we're looking at maintaining between 800 to 2,000 ions per cubic centimeter in the space, which is enough to really do a good job in reducing pollution in our occupied environments. So what we're going to talk about is how the technology reduces particles. We're going to talk about odor control. We're going to talk about pathogens, virus reduction. And we're also going to talk about energy savings by outside air reduction. We're just going to touch on that. And we're going to talk more about how we reduce the biofilm that would build up on your coils to insulate the fins and the tubes, and also add into your static pressure drop. So we're going to go and get into those areas. Our installation base, we've got well over 1,000 K-12 schools where we have reduced the outside air from 5 CFM per student or less. Lots of healthcare applications where we're doing something in there. We are not reducing ventilation air in those applications, but we may be in there to reduce diesel fumes, jet fumes that are coming in from helicopter pads, reducing hospital-acquired infections, just doing a lot of good things. And we can talk more about that here shortly. Well over 300,000 installations worldwide at this point. So, like I said, we're not going to touch on the IAQP, but I just want to make you aware that we do have a spreadsheet that is available to you. that you can run that would profile the IAQ procedure at the same time as it profiles the ventilation rate procedure. And you can see 18 different gases that we are doing mass balance equations on. And then you can see the carbon dioxide level of both the IAQ procedure as well as the ventilation rate procedure, where we are profiling that those levels will be. So we can talk about that in a future webinar if necessary. So the new standard, ASHRAE standard 62.1 2019, now requires UL 2998. Basically says at 5.7.1, air cleaning devices shall be listed and labeled in accordance with UL 2998. So what are these ozone standards? Well, UL 867 2007 is one that's been around for a long time. And what that states, and basically what it is, it's a chamber that UL will put your technology into. They'll operate it for 24 hours, and then they'll measure the ozone buildup in there. If you are 50 parts per billion or less of ozone, then you pass that test. Everybody, I mean, EPA requires 50 parts per billion or less in occupied for your product to produce ozone or less, so you'd be good at that. UL 2998, on the other hand, requires 5 parts per billion or less. So that is in that new standard. If you produce 5,000 parts per billion or less, you can state legally you produce 0 ozone. So it states that any device that requires power to clean the air should have UL 2998. And they're saying electrostatic precipitators, needle point bipolar ionization, dielectric barrier discharge, corona discharge, UV lights, etc. So and we have products that do meet that today in a few minutes. So our corporate offices were located in Savannah until we moved to Charlotte this past November. Gulfstream is also in Savannah. They helped us get through and qualify for DO1 the aircraft certification. What that certification required is no ozone production and no electromagnetic interference, line noise. So we now have that certification. So we are on Gulfstream jets, we're on Boeing business jets, and we're on a Gusta helicopters. We are talking to many different carriers today since COVID-19 came along. So we are in the process of talking to them. So maybe someday we can have our technology on the aircraft that we are flying in. So I'm going to start right away with particulate. It's really important to take the particulate out of our breathing zones today, and we're going to go through that. So if you look at the sunbeam shining through a window on a sunny day, you can see a haze. That haze is just a lot of particulate that's in the air that's the sunbeams are reflecting off of. I like to say that there's 3 different types of particulate that we're looking at right now. Some of the particulate is large enough to be moved by the air currents, comes back to the system filter, and is filtered out. Other particulate is small enough to be moved by the air currents, it gets back to the system filter, and it's too small to be caught by that filter, so it just goes back out into the breathing zone and it's recirculated. There's other particles that's so small, submicron, that is stratified. It does not move. You could have a MERV 13, 14, 15 filter in your system, and unless you can get that to move, you're not going to pick it up by the filters. So what we are doing is called agglomeration. So we are taking positive, negative ions, putting them out into the occupied space, coming in contact with the particulate, and the ions are giving off their electrical charge to those particles. So now we have positive and negative particles. Opposites will attract. So those negative and positive particles are coming together, and we have a snowball effect. We're making those particles larger. So now those particles that were passing through that filter, after a period of time, they'll be large enough to be caught by that system filter. The other particles that are submicron, that don't have enough surface area to move, now through the agglomeration process, they will grow in size and eventually be moved by the air currents, and eventually they'll be large enough to be caught by that system filter. It's important to really take the particulate out of the breathing zone, because older people with heart and lung issues really are susceptible to these particles, and also children with, it doesn't allow the children to really develop their lungs. So we're going to get more into particles as we go along here. Talking about sizes of the particulate. You see fine beach sand, that's 90 microns in diameter. Okay, you see the human hair, 50 to 75 micron in the diameter. Then you see PM10. PM10 is 10 microns. And you see all the way on the right-hand side, PM 2.5, particulate matter 2.5 micron. So you see how small it is compared to the human hair. That's basically microscopic. That's a particle that is stratified. This is a particle that the EPA says you really need to reduce in the breathing zone because of the issues that it can cause to those people that are suffering from respiratory or heart disease. Now, you see the size of that PM 2.5. COVID-19 is 0.12 microns. So it is really, really submicron compared to that PM 2.5. So now, if you have COVID-19 that is hanging in the air for 3 hours, there's no way that that is going to get back to the system filter or back into the system to be seen by UV light unless you're agglomerating that particulate. If that PM 2.5 is stratified, so is that COVID-19. That's why it hangs there for 3 hours at a time. It just does not have enough surface area to be moved by the air currents. So through that agglomeration process, the pathogens as well as virus, asthma and allergy triggers will attach to those particles that are being moved with the air currents now and can be moved back to the system filter and eventually be filtered out. So taking a look at some sizes of the particles again and how it would affect us. You've got PM10. Okay, you can see that can get down into your trachea and cause some issues. PM 2.5, that's small enough to get all the way down into your bronchioles. And then PM1, you see where that is. That can get all the way down into your alveoli. That is where it can transfer go through your lung wall into your bloodstream and cause those asthma and allergy triggers. So COVID-19 being much smaller than that can get even further down there, and that as well will go into your bloodstream, which causes the real issues with the respiratory issues of people that have COVID-19. Now, what we are told is that people that inhale the COVID-19 will get into the lungs, and that's what causes those serious issues. On the other hand, people that just come in contact with COVID-19 may touch their face and they just end up with some sort of upper respiratory infection that's not as serious as those that inhale the virus itself. This is a case study from a pharmaceutical clean room in Pittsburgh. They had a catheter product that they brought in there. It had an odor to it. They contacted our rep in Pittsburgh. They had our technology added into their system with their HEPA filtration. Odors went away. Everybody's happy. 3 months later, the company came in that certifies a clean room. And after he was done with his measurements, he went to management and said, "Hey, what'd you guys do?" All of a sudden, your particles that are smaller than 0.3 micron, which is what we filtered out by the HEPA filter, have been reduced by almost 90%. They said, well, we basically just added in ionization, and that's what did the trick. So even in those real submicron particles that aren't removed by a HEPA filter can be agglomerated and now caught by that HEPA filtration. So if you have a clean room that is out of spec and you've got to ramp up the air changes, now you can add in ionization and it will bring that, ramp those fans down, and you can bring it into spec. We've done some testing. Blue Heaven Technologies is a certified filter testing lab in Louisville, Kentucky. They do, they certify MERV ratings for different filter manufacturers. So we went in there with a MERV 8 filter with our technology. We wanted to see how that compared to a MERV 13 filter without our technology. What we found out is after 16 hours of operation, our MERV 8 filter with our technology exceeded the performance of that MERV 13. Basically, it was because of the agglomeration effect. We kept agglomeration over time, and as time went on, we would reduce more particles. So after 16 hours of operation, we exceeded the performance of that MERV 13. After 34 minutes of operation, that MERV 13 filter could not capture any of the smaller particles that were passing through that filter. Without agglomeration, you just can't capture the smaller particles. So again, you can go to a lower pressure drop filter. You can have better filtration and extend the equipment life, as well as improve the indoor air quality at the same time. National Research Council of Canada did a study with our technology. What they came away with is, it says NPBI there, that's needle point bipolar ionization, which is our technology, with a MERV 12 filter has the same efficiency as a MERV 16 filter. Same efficiency or same effectiveness as a MERV 16 filter. And that, again, is because of the agglomeration process. Here you'll see a study that was done by the Department of Environmental Health, University of Cincinnati. What they did is they wanted to see how ionization affected masks. This is done well before COVID-19 ever came around. So you can see that with ionization, the enhancement factor of the N95 mask is almost 50%. So it's increased the effectiveness or the efficiency of that mask by almost 50%. Over to the right, the surgical mask, it's increased that efficiency by almost 200%. Dust mist respirator, which is what you would find in Home Depot that you might wear if you're spray painting or if you're working in your wood shop, it's increased that efficiency by well over 3,000%. So again, adding in ionization can increase the efficiency or effectiveness of the mask the same way it would a filter. So we're going to get into VOCs and how we affect them. So here you see the ammonia molecule passing through the plasma field. Now, that plasma field it's not where the device is mounted in the unit. The plasma field would be the ionization that is generated by if you had a unit in your fan coil right now, It would be the ionization that's generated and discharging into your space where you're sitting. So we are all off-gassing ammonia at this moment, excuse me. And you have the plasma field that we're sitting in. Every VOC has an electron volt potential. The electron volt potential is the amount of energy that you apply to a VOC in order to break the molecular bond of that VOC. Once that molecular bond is broken, there's a regrouping. Okay, so the ammonia molecule would regroup into nitrogen, water vapor, and oxygen, gases that are prevalent in our atmosphere and harmless to us. So anything that we are capable of breaking the molecular bond with is going to become one or a combination of four things: nitrogen, water vapor, oxygen, or carbon dioxide. Again, things that are prevalent in our atmosphere and harmless to us. Now we have some limitations. Our limitation is any VOC that has an electron volt potential less than 12, we will be able to convert. This is showing you that ammonia molecule. It has an electron volt potential of 10.07. So that was below 12. So we were able to break the molecular bond on that. Oxygen, O2, if we oxidize that, it would become O3, which is ozone. We don't want to produce ozone. So you can see at the bottom, you have the corona discharge tube, and it requires more energy than that 12.07. That would be the point at which you create ozone. It requires greater energy than that to break down the dielectric of that glass tube to get it to conduct electricity. So we're going to get right into mold, virus, and bacteria control. Now, this is showing you a pathogen, okay? The pathogen is being attacked by the ions. It's breaking down the RNA, DNA cell structure, and eventually the hydrogen is removed. So there's lots of other technologies out there that are similar, but they're capture and kill. You'll have some capture and kill technologies that will basically capture a pathogen in an electrified filter and bombard them with ionization, breaking down that RNA, DNA cell structure, and it's removed. However, we're not doing in that 9 or 11 inches of space. We're doing it in the actual space. So whether it is a surface or a airborne pathogen, we will be able to have a positive effect on that and deactivate it. On the other hand, you have viruses, okay? A virus is non-living, and what we do with that is we will break down the RNA membrane on that virus and deactivate it. So here you see some of the tests that we have put our technology through. EMSL Labs is an elite rated lab by CDC. ATS Labs is a lab that does a lot of work for Homeland Security. And you can see some of the pathogens that we have been tested to, the times of exposure, and the kill or deactivation rate. In the past, MRSA and C. diff were the two most prevalent hospital-acquired infections that were the most difficult to eradicate in medical facilities, up until the COVID-19 came along. So now we have to deal with that. Now, COVID-19 is not available at this time to be tested in third-party labs. So just recently, we had the human coronavirus tested. What we found is that after 90 minutes, after 60 minutes of exposure, we had a 90% deactivation rate. And this is with one of our residential products, which has a lower level of ion density to it. So we are going through some additional testing this month, and we expect because of the higher densities, we're going to have a better deactivation rate. What I also want to say here is AI DuPont Hospital in Wilmington, Delaware, has just completed a study. They've used their product for years, and they love it. They did the study because they are looking at replacing 127 of their air handling units, not replacing the air handling units, but replacing the UV lights that are in the air handling units with our technology. So in the past, they've seen a 90% reduction in areas of particulate in areas where they do have our technology. So the study is complete. It's with their attorneys right now. They're waiting to see what they can actually release to us so we can put it in a case study. But what we have been told, the study results, some of the results, they had a 70% reduction of particulate in their ORs, and they had a 37% reduction in bacteria in their ORs. And these are what you would consider a sterile environment. So even though you think it's clean, using our technology, it can even be more sterile than what it is. So if you want to look at our technology versus UVC, our products, we have auto cleaning products, which we'll look at here in a few minutes, but we also don't have any parts to replace. For UVC, you do have to replace bulbs annually or semi-annually, or every 2 years. Neither one of us produces any detectable levels of ozone. UV will, depending on the wavelength. We will kill mold, virus, bacteria in the space where UV has a line of sight only. It's got to see that pathogen for a specific amount of time in order to kill it. But also, that pathogen or virus has to get back to that UV light in order for it to see it. And if it's stratified, there's no way it's going to get back there. We will control odors. UV does not. We'll reduce particulate where UV does not. Our products do not contain mercury, so when you're disposing of mercury of UV lights, they are hazardous waste. Most importantly, there is no degradation with our technology of filters, of insulation, of plastic wire coatings, or those expensive coil coatings that you are specifying today. Then we get right into some of our products. As I mentioned before, we have auto cleaning products. Now, this is a DC product. On the left-hand side, you will see 2 black emitters sticking up, and they're tipped off in carbon fiber. That's how we're charging air electrically. We're using air as a dielectric. We're creating our ionization. We have a positive side and we have a negative side. Now, with that, typically, if we didn't have auto cleaning on there, you would have particulate that would be building up on those emitters of the opposite charge. Over a period of time, those emitters become insulated by those particles, reducing the output. It can reduce the output severely. So the wiper blades will go back and forth once every 3 days and knock that particulate off, and it will bring it right back up to spec. So this is something that basically you can install. It's very little to no maintenance, no replacement parts, and you're off and running. Now this is the FC24AC. FC would stand for fan coil, 24 up to 2400 CFM. AC is auto clean. We do not have a voltage designation in the model number because it is universal voltage. This is good for 24 through 240 volts, just through your black and white wires. Just tie it in, you can't mess it up. 24 through 240, and it operates at full output. Unit comes with rare earth magnets, so you can easily install it, the magnets on the bottom tabs of the side tabs. And this is something that you could put into a 3x3 cassette. You could put it into a low profile ducted fan coil. You could put it into any other fan coils up to 2400 CFM, upflow furnaces, lots of different applications for this. The unit is only about 7 inches long and about 5 inches high, so it will fit a lot of various applications. Then we have our auto cleaning FC48 AC. This is good for up to 4800 CFM. Again, the same 2 wires for power, 24 through 240 volts. You will see some purple wires coming out. Those purple wires are basically a set of normal open contacts. If you want to tie it into a building management system, you can. What happens is those normally open contacts will close when it senses that the electricity or the voltage is at a point where you can generate ionization. So it's not just that it's on, it's reading the proper voltage is available. This is something that I would use in a upflow furnace, 0 to 4800 CFM, a fan coil, a small pack rooftop. You can go up to a 12.5 ton rooftop with this and just sit right in the fan section. Or if you have 15 through 25 ton, you can double these up and put these in the fan section and have ionization in your space. Also, let's say if you have an upflow furnace and you are blowing the ionization through the evaporator coil, it's going to sanitize that evaporator coil. So it's going to break down the biofilm. You're not going to build up that crud on the coil. You're going to reduce the static, prevent it from getting clogged up so it doesn't increase the static pressure across the coil. And also, one thing about this, it will kill the bacteria that creates dirty sock syndrome. So with our technology, even if you have dirty sock syndrome, this eventually will kill it.
Hey, Bill.
Yes.
We have a couple of questions, if you don't mind.
Nope.
Okay. Question number 1. What is the lifespan of the ion created by your product?
Approximately 60 seconds. So you can figure the velocity in your duct and the length of your duct, and you can actually see what kind of lifespan you're going to have left of that ions once they get into the space.
Okay, thank you. Question number 2. Location of these ion generators, supply duct or return duct?
Both this one and this one, you would put between the filter. If you can get it between the filter and the evaporator coil, downstream of the evaporator or upstream of the evaporator coil, that would be ideal. However, if you can't, if you can get it in the fan section, that would be the second best place. If you can get it before, it always has to go downstream of the filter. But if you get it upstream of that evaporator coil, you can sanitize it. But if you can't, well, putting it in the fan section is, again, the second best place.
Okay. I have 2 more questions. Slide 13, are the test results based on a new filter? What is the effect when the filter is at the end of life? Example, many PA agencies lack the ability to measure differential pressure across the coils and lack a PM schedule. How would the ratings be affected?
I'm not quite sure if I completely understand. Now, which slide was that?
13?
I don't see numbers here, so tell me when I get to where you want.
I'm not sure.
Okay.
Bill, I'm sorry to interrupt. It's the slide where, yeah, that's it. MERV 8 plus MERV plus GPS equals MERV 13.
Yes.
That's the slide.
Okay, now what was the question?
All right, let me go back to it. Are the test results based on a new filter?
Yes.
Okay. What is the effect when the filter is at the end of life?
That we didn't measure. We only measured for a total of 16 hours. So we would not have the effect that end of life rate at this point.
Okay. Couple more questions. I mean, they're starting to roll in here. When installing your equipment inside an AHU, is there a minimal maximum air velocity range to stay within the achieve the published efficiency rate?
Actually, the higher the velocity, the more ion density that we will generate. So if you are in a duct, a supply duct, with the next product that I was going to show you, it would have a higher velocity. You'd probably be getting more ion density. And the reason I'm saying that is because in aircraft applications, we get a much higher density with the higher velocity systems than we do with just our standard applications. Our iMods, which is a bar type product that goes across the entire width of the evaporator coil, we're typically 550 feet per minute and less with that. If you mount that in a supply duct, you're going to get a higher density of ionization. So wherever we are, whether it's one of the DC products or whether it's our iMod, standard velocities will work just fine.
Okay. Do all the products have the same UL rating?
Well, they're all tested to UL 867 now, and I'm going to get into some of those here in a few minutes. But this one that we're looking at right now, we had this tested by Intertech about 2 or 3 years ago, and the ozone on this one, we were at 0.006 parts per million. We need 0.005 to make UL 2998. So with that, we have taken all of our auto cleaning products, tweaked them just a tad, and sent them back into UL for testing. So they're in there right now for recertification, and we are anticipating that we're going to have UL 2998 on all the products that I'm showing you today, which would be zero ozone production.
All right. I'm just sending a note out right now, basically asking everybody, look, it is great. We love the questions. I want to let you get through this, and then we can go back and answer their questions. How does that sound?
Mm-hmm.
Okay.
That works. Thank you.
Yes, sir.
So anyways, this is a duct mount unit, the DM48AC. DM stands for duct mount 4800 CFM AC auto clean. So this takes a 4-inch round hole in the duct, 4 zip screws. You basically screw it in, wire it into 2 wires, and you're off and running. This is something that you can put into your supply duct, but when you put it in the supply duct, you're missing that evaporator coil to sanitize if you have a chance of doing that with the FC48. Same output. I don't think I've talked about ion densities. This unit here puts out about 150 million ions per cubic centimeter. So a very high density of ionization if you look at any of the other products that are out there. This one puts out 200 million ions per cubic centimeter. This one, again, puts out 200 million. This is the same as the other one we just looked at. However, it's duct mounted instead of unit mounted. So we could mount this in the supply duct, or if you have a zone system with VAV boxes or zone dampers, you could put this at one of or after one of the VAV boxes. If you have a issue, let's say you have a tenant building and you have somebody that has an issue with their neighbor that's smoking in their office all the time. That smoke is infiltrating their office, and they're not very happy about it. So you could actually take a unit like this, put it in that duct that's feeding that one zone, and it would be the zone that the person is complaining because the smoke in there is not as heavy, so it's easier to treat than the person that's smoking. We don't want to help that person out. We want to help the person out that's complaining. So you put this in there and it's going to take care of that. With that, you don't have to treat the whole building. So let's say if you have a 40 or 60,000 CFM central station unit that's providing air, heating and air to the whole space, you don't have to treat the whole space. You can just spot treat it with one of these. Then we come to our flagship product, GPS iMod. The GPS iMod is a modular bar. It basically fits across the full width of an evaporator coil on the inlet side. So what we are doing is we are generating ionization that's going to go through the full face and depth of that evaporator coil, keeping that evaporator coil clean, not allowing the biofilm to build up, not allowing the static pressure to increase. It will keep that coil nice and shiny. You probably won't have to do any cleaning on it unless you have some bypass of stuff that's coming past your system filters. And then the ionization goes into the space. So this is a modular product that we ship in 6-inch sections. However, when it's sold, the contractors would give us the width of the evaporator coil and the height of the evaporator coil, the number of coils, whether they're stacked, whether they're staggered, and then we would go accordingly. But we can power up 4 12.5-foot bars with one power supply, and it's only going to use 15 watts of power. So easily a 40,000 CFM air handling unit. We can sanitize that coil, plus go out into the space, treat the space at only 15 watts of power. This is the unit that has passed DO once, it's passed UL 2998. There's that little sticker on the left-hand side that states that it's validated that we've passed it, and we can use that sticker. This would mount, again, upstream of the evaporator coil. Now, in a healthcare application, if you have final filters, the ionization is going to be stopped at those filters. So in many cases, we will put another set of bars downstream of the final filters to provide ionization into the actual space. Where you don't want to add in ionization into a hospital setting, if it's a unit that's supplying ionization or air to a research area, the ionization will have a negative effect on open petri dishes. I've been told that years ago, there was an ionization device installed in a system. It wasn't ours, at the University of Michigan, and it destroyed a 40-year-old study that was in an open petri dish. So we want to avoid those at all costs as well. So if you want to see a typical installation, here it is installed on a system. We have multiple bars that it's showing here, but we would go to 1 bar for 60 inches of total height on a evaporator coil. If you have multiple coils or stacked coils, we'll go to 1 bar per stack. If you have staggered coils, we'll go 1 bar per stagger. And if you have heavier odors, such as diesel fumes or jet fumes, we'll go to 1 inch of bar per 100 CFM. We've done a great job in reducing diesel fumes as well as jet fumes at hospitals. And recently we did some testing at a hospital in Florida, and we had a 75% reduction on jet fumes in a single pass. So it does a real good job of killing those odors as well. So here's our power supply. This is a split screen here. It's 2 different pictures. They're not related one to the other with the application. But this is actually how it would be installed. Now, with this product, we're producing 60 million ions per cubic centimeter of 60 per inch, okay? So 60 million ions per cubic centimeter per inch. So let's say you have a 10-ton system. The 10-ton system with that FC48, we would have 200 million ions. But let's say we're putting it in the fan section, we're not really sanitizing the coil. Excuse me 1 second. Okay, if you were using a iMod on the same application, you might have 60 inches of total bar. So that would provide you with 3.6 billion in lieu of 200 million. So a much higher density of ionization. It's going to do a much better job. It's going to sanitize that coil before it goes out into space. So for measurement and verification, okay, so how do you know that it's working? A lot of different sensors that we have available to you. The first thing that we have in the upper left-hand corner is an air ion counter. You can use a handheld air ion counter in the space to measure the ion density in the space after you have started up the equipment. And you can have another ion air sensor of a different sensitivity that you would use at the device itself to see what the actual ion density is putting out at that point. So that's something that you would use possibly on commissioning. Also down below, left-hand side, you've got that laser particle counter. That laser particle counter you can use before you start up ionization. Then you use it a couple days later just to see what the particles were that you had before and what they are after. And you can see the reduction in particulate. We've got a couple sensors that could tie into your building management system that would actually read ion densities. The one on the left-hand side, the black one, is the GPSI measure that would mount in the space, and that would read the actual ion density that is in the space. Report back to the building management system in a 0 to 10 volt signal. Same thing on the right-hand side, the GPSI measure D, that's something you can mount in the duct or at the device itself. And again, telling you the actual ion density is being produced by the product that we have in the air handling unit. Down below, you see that little GPS iDetect P that's attached to the iMod bar. That is a device that you can use to, if you want to see the ion field that's being generated from the iMod bar. What it's going to do, it has a set of normally open contacts. All it's doing is telling you that we have enough of an ion field that's generated, and the set of contacts will close. It can go back to the building management system also and say, hey, I'm on. It's a lesser expensive way of doing it than going to one of the GPS eye measures. And then if you want to measure total VOCs in the space, you would go to the metal oxide semiconductor. That is a BAPI sensor that is shown. That does a good job in measuring the total VOCs that are present in the space. If you want to measure before and after with a very high-end photoionization detector, you can do that with the one that's showing on the right-hand side, the TVOC2. These also tie into your building management system, and this is what you would use if you want to measure before and after. We have tried using the BAPI sensors for measuring before and after in the past, and they gave us incorrect readings. The way that they recalibrate to the background, so at sometimes you'll get higher readings in the actual space than you do before ionization. So it just wasn't working with us for us. So we've gone to the photoionization detectors, and they've done a great job. This is something that you can source. Also, there's particle sensors. that can tie into your building management system through BACnet or Modbus. These have a little wand on them, the tube. You can tie it right into the duct, and you have different lengths of probes depending on the width of the duct, or you could have it wall mounted. You could mount it right on the wall itself, and it would be doing the same thing in the space. So a lot of things for verifying that the system is operating properly. So that is basically the end of my presentation. So I guess we can take questions at this point.
Okay, so we have quite a few here. How effective are the negative and positive charged ions at reducing particles and neutralizing VOCs within the space itself, beyond the plasma field within the duct/equipment?
Well, I mentioned just a few minutes ago that we had a 75% reduction in jet fumes from helicopters at that hospital in Florida. So very effective in reducing VOCs. Also, I mentioned that the AI DuPont Hospital, we had a 90% reduction in particulate on a regular basis. We have done other studies, NavCan, which is the organization that controls all of the air traffic control towers. We've done testing in Edmonton and also in Calgary, where we have our product. They had forest fires, the past couple of years, and they were complaining about all the infiltration of the smoke that they had. So again, we had the same reduction, 87% reduction in the particulate, which is directly related to the smoke. So it did a very good job there in reducing the particulate that was creating the issues.
Thank you. How often do the carbon needle tips need replaced?
Never. The auto cleaning products, which you saw, we've had, we are estimating the product will last about 10 years. They are replaceable, but we've done cycle testing that's been well past 10 years on them. There's very little friction with the blade that goes back and forth every 3 days. And the testing that we've done has been we just have it running continuously. And there's really been no wear on the emitters or on the wiper blade.
Thank you.
Let me just get to the iMod.
Yeah.
The iMod is an AC product. And what we're doing is we're alternating the polarity on that. So where the DC products, we're going to have opposite charged particles attaching to those to that. On the iMod, what we're doing is we are alternating the polarity on that 60 times a second. So you don't have a positive or a negative side. We're alternating the polarity, creating a pulsing. So we're always pulsing away the particulate that would want to stick on there, but it can't stick because we keep pulsing it away 60 times a second.
Okay. Is this product recommended for use in vivariums?
Yeah, we did a study at the University of Maryland, Baltimore, where they did a week test of the Corona discharge type product in there. They ran it for a week, and then they ran our product in there for a week. And they decided to stick with our product, and they ordered our product and they installed it for the vivarium and didn't go with the dielectric barrier discharge. But there he was measuring everything. He was measuring ozone buildup. He was measuring particulate. He was measuring VOCs. Everything he could measure, he was measuring. So he preferred our product.
Okay. How does GPS match with competitors' BPI product?
Well, no tubes to replace, no ozone production. When our competitors that have the bipolar ionization that state they do not produce ozone, most of them have not been put up against that UL 867 2007 ozone chamber test because they've been grandfathered in if they have a duct mounted unit. All of those BPI units that have tubes are typically duct mounted, so they've been grandfathered from that. What's going to happen is once this ASHRAE 62.1 2019 comes into effect, that's going to change everything. A lot of it's the ozone output. A lot of the dielectric barrier tubes, they'll put out maybe 100,000 to 200,000 ions per tube. Not anywhere near the ion density what we produce. So reducing that particulate, we do a much better job without any ozone production.
Okay. Does having more ions extend the life of the ions past 1 minute?
Well, what we're doing is basically replenishing those ions that are going to last only a minute. So we keep pumping, we're running the fan continuously, so we're always dumping in ionization into the space. So you always have fresh ions coming in that are going to eventually dissipate.
Okay, next question. Since your equipment reduces the amount of particles in the air, have you considered using your equipment to decrease the air change rates for clean rooms?
No, we haven't. That's not really something that I guess would be in our charter. That would be something that they would have to, I guess that would be in a different area. But I guess it could happen.
Okay. Can the ions from the iMod pass through supply HEPA terminal, filter, and into the room?
No. As I mentioned before, those filters are going to stop the ionization. And unless you have another set of bars downstream of your final filters, it will not reach the space.
Okay. And what are the tolerance of the sensors or sensor yearly drift?
I'm not a sensor guy. We can get you that information. That's not something that we typically would sell. So I could give you the name of those manufacturers, and you could look into that. Except for the eye measures, and I don't really have those numbers in front of me right now. But if there's an interest, we can get those for you.
Okay. What is the voltage at emitter?
Probably about, I measured it yesterday. I was doing a hands-on presentation, and I was measuring the voltage. And at the auto cleaning, I was measuring at about 5,500 volts DC. You got DC positive on one side, you got DC negative on the other. And on the iMod bar, I think I was reading about 6,500 or something. We want to read between 4,000 and 7,000.
Okay. Next question. Is there budget rules of thumb that they can use to estimate costs to install? I'm going to answer this one. If somebody's looking to put something together, we would ask that you would call and work with whoever you're dealing with from our company. and we will put together different budget scenarios for you. Okay. Last question is, are there any gases generated with the process, and if so, what are they?
There's no gases, there's no byproducts, no ozone. No, there are none. When you put our technology in, you have a lack of odor. You don't have any distinct odors that are generated at all.
Okay. H2O2 question mark.
Help me out there. Was that hydrogen sulfide?
H2O2, would that be hydrogen oxygen?
Hydrogen peroxide.
Oh, hydrogen peroxide.
Oh, no, no hydrogen peroxide at all. No.
Does the GPS unit get turned off when the unit is turned off?
That is personal preference. You can power it 24/7, 365. And the reason we can do that is because there's no odors that are being generated. So a lot of times when you have, let's say, a PCO type product that's producing ozone, you will have ozone building up in the fan section when you're cycling. And then upon startup of the fan, you'll get that ozone, a burst of ozone into the occupied space. With us, you can leave it powered 24/7, or you can cycle it with the fan. It doesn't really matter. It's personal preference.
Okay, that was the last question. If anyone, we'll do a last call for questions here. And otherwise, not seeing anything.
I'm sorry, Buck, there was a question that was dismissed. I don't know if that was a mistake. It says, is Active Air Solutions, parentheses, AAS, the same company as GPS?
No, it is not. It is a private label, and they have a limited product offering, and they don't have the backup and support as a full organization such as GPS.
Thank you.
Okay. All right. Well, thank you everyone for attending. If you have somebody that you think would see some value in this presentation, we are having the same presentation next Thursday, the 28th, at the same time. And once again, we really appreciate you taking the time to join us today. And everyone have a great day, and thanks again.
Thank you for all attending.